Another thing that we can measure is capacity and volume. Volume and capacity are used interchangeably, although strictly speaking, they mean different things. So, how can we differentiate capacity and volume? So, let's take a look at the following bottles. They all look different in terms of shapes, heights, colors, and liquids inside, but they have one common property. The amounts of liquids inside the bottles are the same. Each bottle holds 2 liters of a liquid. So we see that all bottles have a common property. This property is the amount of space they have for holding a liquid. This space is called capacity. So we can say that all these bottles have the same capacity. Sometimes the amount of liquids inside of different bottles or jars are the same, but the capacities of the containers are not the same. The following cylinders, which all have different capacities, but the amount of liquids inside all the cylinders are the same. This amount is called volume. Volume represents the amount of a liquid or how much space the liquid takes up in a container. Shown below are examples of metric measurements of capacity and volume, like syringe, graduated cylinder, a tin can, and a bottled water. So now let's discuss volume. Volume is a derived unit, meaning it uses the base units in formula. We know previously that it measures three dimensions: length, width, and height. And if we are going to find the volume of this box, which all sides measures 10 meter for example, then the answer has a base unit which is meter. But what differentiates unit of measurement of length from volume is that instead of multiplying or dividing the given measurement by powers of 10, we do powers of 1000. The commonly used metric units for volume are cubic meter or cubic centimeter. And to further understand this and volume in conversion, let's have an example. So convert 78 cubic meter to cubic decameter. Based from the metric system line, how many steps do we need to make from meter to decameter and in what direction? That's right, we need to take one step to the left. Since we are converting smaller units to bigger units, what operation we will use in the conversion? Okay, the operation we will use is division. But since we are talking of volume, each step will be 1000. So using the factor label method, 78 cubic meter is equal to 78 cubic meter over 1 times to the equivalent relation of conversion, which is 1 cubic decameter all over 1000 cubic meter. So canceling the similar units and multiplying the fractions, we get 0.078 cubic decameter or 78 thousands cubic decameter. Another way of solving this problem is by moving the decimals. All we need to do is to move the decimal point of 78 three times to the left. This is because we are dividing 78 by 1000 and 1000 has three zeros. So therefore 78 cubic meter is equal to 0.078 cubic decameter. So let's have another example. Convert 587 cubic meter to cubic centimeter. Based from the metric system line, how many steps do we need to make from meter to centimeter and in what direction? Okay, so we need to take two steps to the right. Since we are converting bigger units to smaller units, what operation we will use in the conversion? The operation we will use is multiplication. But since we are talking of volume, each step will be 1000, and we will have 1 million as the multiplier because we take two steps, which means 1000 times 1000. So using the factor label method, 587 cubic meter is equal to 587 cubic meter all over 1 times to the equivalent relation of the conversion 1 million cubic centimeter all over 1 cubic centimeter. So canceling the similar units and multiplying the fractions, we get 587 million cubic centimeter. Using the shorter way, and this is by moving the decimals, all we need to do is to move the decimal point of 587 six times to the right because we are multiplying 587 by 1 million, and 1 million has 6 zeros. Therefore, 587 cubic meter is equal to 587 million cubic centimeter. Let us now try solving this problem. How much water in cubic centimeter will a 0.04 meter times 20 centimeter times 10 decimeter tin can contain? So first, I will ask you, what can you observe from the unit of measurements in the given problem? As you can see, they all have different unit of measurements: the meter, centimeter, and decimeter. But analyzing the problem, we just need to find how much water in cubic centimeter. With that being said, we need to convert meter and decimeter to centimeter. Take note that in metric system line, 1 meter equals 100 centimeter and 1 decimeter equals 10 centimeter. So 0.04 meter will be 4 cm and 10 decimeter will be 100 centimeter. And now we can find the volume of this tin can because the unit of measurements of the given items is now in centimeter. So 4 centimeter times 20 centimeter times 100 centimeter gives you 8,000 cubic centimeter. Thus, 8,000 cubic centimeter is the amount of water that a tin can have. And now we move forward to capacity. Capacity is the accepted unit to use with SI units. Remember that in unit of measurement for length, meter is the SI unit. But in capacity, we change the base unit to liter. But did you know that liter is not a SI unit? But it is considered as the accepted unit to use with SI unit and one of the commonly used metric unit aside from milliliter. With that, what we do in converting unit of measurement for length is the same as converting unit of measurement for capacity, and we just change the base unit of meter to liter. And to further understand this conversion of capacity, let's have an example. So convert 78 liters to decaliter. Based from the metric system line, how many steps do we need to make from liter to decaliter and in what direction? That's right, we need to take one step to the left. Since we are converting smaller units to bigger units, what operation we will use in the conversion? Okay, the operation we will use is division. But since we are talking of capacity, each step will be 10. So using the factor label method, 78 liter is equal to 78 liter over 1 times to the equivalent relation of conversion 1 decaliter all over 10 liters. So canceling the similar units and multiplying the fractions, we get 7.8 decaliter. Using the shorter way, and this is by moving the decimals, all we need to do is to move the decimal point of 78 once to the left. This is because we are dividing 78 by 10, and 10 has one zero. So 78 liters is equal to 7.8 decaliters. Let's have another example. Convert 321 liters to centiliter. Based from the metric system line, how many steps do we need to make from liter to centiliter and in what direction? Okay, so we need to take two steps to the right. Since we are converting bigger unit to smaller units, what operation we will use in the conversion? Okay, so the operation we will use is multiplication. But since we are now talking of capacity, each step will be 10. And we will have 100 as the multiplier because we take two steps, which means 10 times 10. So using the factor label method, 321 liter is equal to 321 over 1 times to the equivalent relation of conversion 100 centiliter over 1 liter. So canceling the similar units and multiplying their fractions, we get 32,100 centiliter. Let's check if this is true by moving the decimals. So all we need to do is to move the decimal point of 321 two times to the right. This is because we are multiplying by 100 and 100 has two zeros. So 321 liter is equal to 32,100 centiliter. Now let's try solving this problem. Carol has 2 liters bottle of juice. How many glasses can it fill with 200 milliliter of juice? In the problem, we see that 2-liter bottle of juice will be distributed to 210 milliliter of glasses. So first, we are tasked to convert 2 liters to milliliters. 2 liters is equal to 2 liters over 1 times to the equivalent relation of conversion 1000 milliliter over 1 liter. So canceling the similar units and multiplying the fractions, this gives us 2000 milliliters. And now we are going to divide 200 milliliters by 210 milliliters because we want to know how many glasses can we make from a 2 liter of juice. So 2000 milliliter divided by 210 milliliter gives us 9.52. Thus, Carol can fill 9 glasses of 200 milliliter of juice from a 2-liter bottle of juice. Between capacity and volume, the unit of measurement that is more often used is liter than the cubic meter. Since capacity and volume are connected to each other, did you know that at 1000 cubic centimeter is equal to 1 liter? So let's try some problem that involves both capacity and volume. This is the problem. A pool is 15 meters long and 10 meters wide. If it is filled with water to a uniform depth of 1.5 meters, how many liters of water are needed? In this problem, we are tasked to find first the volume of the pool given the dimensions 15 meters long, 10 meters wide, and the depth of 1.5 meters. But upon looking on the metric unit used, it is in meters. So the first thing that we need to do is to convert the given measurements to centimeter. But based on the metric system line, how many centimeters are there in 1 meter? Okay, so there are 100 centimeter in 1 meter. Now we will convert the given measurements. If we have 15 meters, we have 1,500 centimeters. If we have 10 meters, we will have 1,000 centimeters. And in 1.5 meters, we have 150 centimeters. Now that we get or convert the given measurements in centimeters, the next thing that we will need to do is to find the volume. All we have to do is to multiply all the converted measurements. So 1,500 centimeter times 1,000 centimeter times 150 centimeter gives us 225 million cubic centimeter. Now that we already find the volume, we can easily convert it into liter using the formula 1000 cubic centimeter equals 1 liter. So 225 million cubic centimeter is equal to 225 million cubic centimeter over 1 times to the equivalent relation of conversion 1 liter over 1000 cubic centimeter. So canceling the similar units and multiplying the fractions, we get 225,000 liter. So therefore, the pool needs 225,000 liters of water. And that's the end of capacity and volume.